So today's class is the kickoff of our second half of the year series. Again, looking at plan review, and so today is going to be more of an overview of commercial energy code plan review. The first Thursday of every month from now until December, we're going to take pieces of the plan review of the energy code and apply the plan review process to it. So today, like I said, is going to be that little bit of overview. If you do have questions, feel free, raise your hand, put them in the chat. Let's talk about what we're seeing and what we're getting and how we can better facilitate. I have not given up on our plan review checklist and more importantly, plan review guide. When you think about plan review, there's multiple ways we can talk about it. I am not a checklist kind of guy. I have checklists. I've used checklists before. And a lot of times checklists seem to project a belief that what we're doing is a full, thorough review of the code. And even in that context, because you're checking off different sections. That really is not unless you take the entire code book, you're really not doing that. And so I usually like to refer to it as a guide in what it is we're looking for, and then where can we find different code sections that relate back to that particular topic. And so we'll as we develop that guide, I'm really hopeful to get it done before our next plan review session in what is this? That'd be August. So get it done this month to where you guys will be able to have it and just use it as a way to, again, show you common concepts and then where to find them, how to describe them, and how to best to respond or provide comments. So I think any process, whether we're talking about plan review or inspections, requires us to understand why we do it. And once we understand that why, we can fundamentally understand the why, then we can really get into the how we accomplish it. And we've talked about this before, and I talk about it every time because I think it's important for us to reinforce that the reason we have codes is to provide minimum expectations of what it means to be safe in the construction that we have throughout New Mexico. So should be minimum expectations to provide a consistent level of expectations across the state. So whether I'm building in Clovis or Artesia, Las Cruces, or Albuquerque, I should have some general idea of how buildings would go together. And one of the things that really has started to come out of that process is the energy codes, right? We know the energy code was updated back in 2024. And so part of what we're looking at is again, making sure that we have a consistent understanding of what it means to be energy efficient, to be conscious of the amount of energy consumption we're doing. It's not necessarily pulling one energy fuel system or promoting one over another. It's all about that flexibility. It's all about that innovation. And so whether we're looking at a design that calls for natural gas or electric or provided electric or even on-site renewables, what we're looking for is how is this building going to effectively use that energy, and what systems, what components we're putting in place to accomplish that. Now, there's a lot of slides in today's class, so again, hopefully we'll do a quick overview of these concepts, and then we'll drive a little deeper into them as the weeks come by. But if you do have questions, make sure you let me know. Now, remember, in the energy code, there's two primary sections. One focuses on the commercial concept of a building, which commercial by the IECC definition is anything that's not residential, right? So obviously, if we have a commercial section, which comes first, and it tells us there's something called a residential building, then obviously that means there's a residential section. And again, that residential section reaffirms that what we're talking about is not just the items that fall under our traditional residential construction code, but we're looking at those one and two family detached dwellings, as well as those multiple single family dwellings like townhouses, like those R2, R3, R4 buildings, occupancy buildings that are 3 stories or less above grade, right? So when we start talking about what the residential provisions apply to, it's more than just single family, 2-family dwellings. Again, it's those group homes, those assisted living facilities. We've got one here, it's an assisted living facility. It's 2-story. It's not a very it's a robust campus, but it's not a tall campus. Now, once we get over that 3rd story, we move into that 4th story, then we revert back to some of the commercial provisions, because in those commercial provisions, it gives us some, again, non or other than R, or gives us some R occupancy considerations, because we know not everything's going to be 3 stories or less in the residential space. And so that's when we start talking about how do we split the building, right? I'm doing a class on firewalls and fire rated assemblies next week. And so that's part of that conversation, is how are we separating occupancy types within a building, is also what we start looking for in the energy conservation side of things, right? How do we isolate what is the residential and what is the other occupancies in a building? And one of the things we see throughout the code is, again, this concept that when we have mixed use buildings, we're applying those requirements respectively, right? And that's not really, when we really get down to it, it really doesn't. How do I say it? There's not a lot of difference between the two. I was doing a project last week or earlier this week where the first floor was a repair garage and the second floor was going to be residential, two single family dwelling units, right? And so what we ended up seeing was they were trying to apply the prescriptive wall insulation values between the two through the single assembly. And one of the things I had to have that conversation with them was, okay, we can do this. We just need to understand that what we're doing, right? We understand that this is a and then it was more interesting. It got more interesting as we got into it, because it turned into it was actually a metal building, right? And so now it's a metal building, and a metal building is going to be treated differently than a traditional wood frame building. And so that's where we have to understand the type of construction we're dealing with to really get to what is the right thermal resistance values. And again, that's part of that walking through the system, understanding when it's a residential, when it doesn't have residential components. Some things are clearly not residential. They're office spaces, they're convenience stores, they're hospitals. And so those are going to be a little bit easier to follow. One of those things that I think is fundamental to understand at the very outset, the very beginning, usually when I take my notes, and I'm still old school, so I still write plan reviews on a sheet of paper. I was actually starting one, but so like when I do plan reviews, I still old school write it out. The first thing I put on there after climate zone is compliance path, because those are two things that are immediately going to affect. One, I need to make sure I'm in the right building, right? We'll go through this here in a second. I'm in the right building. I've got the right community. I've got the right, depending on where I'm at in Bernalillo County, I might be in a 7, I might be in a 5, right? If I'm in Clovis, I'm in a 4. If I'm in Hobbs, I'm in a 3, right? So there are going to be different expectations of how that building's going to perform. And so that requires me to understand the compliance path. We know that in the code there are two different options, two different referenced options. There's the IECC and the ASHRAE 90.1. Now, 90.1 has within it 3 different options. We'll talk about those differently. But when we're looking at the energy code, really what we're looking at is how are we going to rate it? How are we going to expect compliance to be demonstrated? Is it prescriptively through the items listed in on the building plans, or is it through some performance evaluation of the building's operations, right? That's when we take into account the impact of insulation and windows on equipment operations. And so we're looking at a different thing. So again, those are the options that we're given, and each one has its own fundamental way. Now, we've talked about them before, but I think it's always important to understand the compliance options. Now, I do have this conversation and with when we get into the concept of alterations, right? When we do an addition, if we were going to talk about chapter 5 really briefly, when we do an addition, we treat it as a new building. When we do an alteration, it's really important that we read that chapter 5 to understand what's the scope of our project before we immediately jump into Well, any alteration has to follow all of the provisions of the code. That's not exactly what it says. And so we'll talk more about existing buildings in a couple of weeks, but I really want to make sure that especially if you're looking at an ASHRAE 90.1 project, it's really important to pay attention to those scoping conversations, because some of them can have some significant impact. And we've had a lot of times where contractors and designers have done more than necessary, which I'm not saying is bad, but more than necessary. And then they'll come back and say, well, that was a lot of work for a very simple alteration. Well, that's because you did more than what the code told you to. We didn't tell you had to. You chose to do it. And so we just assume that's your project's intent, right? And so again, we'll digress for that for now. We can have a conversation about that later. But one of those things that, again, when we start talking about that is, again, prescriptive is follow the code. This is the straight linear approach to it. Performance ratings, again, like I said, is really going to drive us back to 407. And 407, whether we're talking residential or commercial, performance rating is really about how do we calculate energy use, energy consumption. And then we make sure that energy consumption is 80% of the annual energy based on our standard reference design. I left this little break here so that we can make it easier for me to pull out the standard reference design. But what we're looking for is, again, let's say to operate this building, whether it's a hospital at $100,000 or $200,000 a year in operating expenses, or a residence at $1,000 a year in operating expenses, what we're saying is there's a standard design, a comparative building that we put through a model of operations. We compare that to our proposed design and operation schedule. And then we say, okay, how much does it cost? And are we at least 80% of that value, right? In residential, it's a little bit different. In commercial, we're looking for 80%. So we want to show that we're saving 20% over the traditional design, the standard reference design. Now, that standard reference design comes out of the tables provided in C407. So it's not that we're trying to be 20% better than the prescriptive path. What it is that prescriptive path has a baseline reference standard that goes back to the 2009. So we're trying to be 20% better than we were in 2009. So I think that sometimes can be confusing in how we scope and think about these projects. But remember, what we're looking at is, how does this building perform dollar for dollar versus that reference standard? And we're going to do a deeper, if I remember correctly, we're going to do a deeper dive into the performance and energy rating compliance paths later on in the fall. But what we're going to get to is part of that process. So again, prescriptively, we're going through the process. We're looking at all the tables. We're looking at the detail sheets in the construction documents. When we start looking at it from a building performance perspective, we're looking at a report, right? We're going to get a report back that says, here's the proposed design. It's going to tell me what type of insulation they're going to be using, what kind of mechanical equipment's going to be in the building, and then how much is that going to affect the overall cost of the building, which is going to be in this little section here. It'll have the performance standard, it'll have the proposal, and I'll be looking at that number, and there's usually a green bar that's going to tell me how well it performs in relation to that reference standard. But again, what we're looking for is documentation. So if they say we're going to do a performance report, or we're going to do a performance compliance path, okay, where's my report? A lot of times what I prefer, and this is where you get into that preference versus what the code actually will allow you to tell them, in that process, I prefer that be actually sheets put onto the construction detail. I don't like and I get it both sometimes, which is great, I guess. I'd rather have it on a full 24 by 36 sheet versus an 8.5 by 11 packet, simply because once we get on site, that 8.5 by 11 packet is going to disappear, just like everything, just like, when you ask them, where's a copy of your permit, right? It's going to get lost. Whereas if it's on one of those sheets, then we can know it's sheet E1 or EN1, wherever it might be. If it's a G number for general information, putting it in that construction detail really makes it easier for everybody throughout the process to understand the full impact. so that when we start talking about what can I modify, we can drive back very quickly to that page and say, well, wait, this is going to affect, if this is one of the things that I've seen coming up really a lot recently is the impact that some of the, especially in residential, the impact of the A2L refrigerant conversation on equipment selection. Right, I've got several projects that have come through recently that are still calling for 410A systems, and then again, this I can speak for a little bit from personal experience on this one. You scope out a 410 system, and then you find out that the production pieces aren't available. You can have half the system in this particular refrigerant model, but then you can't get the other piece, and so you may have to change the equipment at some point. That's going to be a normal reality for the next couple of years. And so how is that change out going to affect performance? Right, it's not just changing it from, it's making sure that we're getting a refrigerant change is fine as long as we're still getting the right amount of BTUs and airflows. Right, a wall or a window change out, how is a window going to be affected if Anderson's not making my window and I need to go with a Pella, or if I'm not doing site built, or I am doing site built. This putting that detail here on a construction sheet versus in a report, to me, is always going to be more efficient. So for those our designers that are there, this is something I like to see. I think it really does support your relationship with your plans examiners. From a jurisdictions perspective, I usually push it a little bit harder than I probably should have, but that's just me, and I live in a small jurisdiction. So once I push it once, it's kind of understood what we're expecting to streamline. Otherwise, it's going to be a little bit more. In my jurisdiction, which I guess I realize more and more recently, every jurisdiction is different in how they bill and permit and the fees we've charged. My plan reviews, where I live, they're based on the hours it takes to review. So if it's a quick review, it's a lot cheaper than if it's a longer review, because I have to search through multiple files, even electronically, to track things. So I digress a little bit there. Again, like I said, ASHRAE 90.1 has a variety of different options in that they have a prescriptive model. They also have the energy cost, which is our performance rating, as well as a performance rating method of evaluation. That performance rating method of evaluation is really more about how we grade the building, right? It's really it's giving it a value versus the cost, the dollar value, right? Who does the review. So normally when I see this kind of a review, this is from an energy modeling. So this is coming from the design side of the conversation. So you can use, there are a variety of different applications there that provide this type of energy report. And so sometimes I'll see that they will normally employ, as a part of this process, they will hire this company, whoever that energy rater is going to be. That energy rating company is going to send someone out to verify, because I think this is a good point to make. When we're following one of that total building performance method, the inspector does his job, right? He's going to verify insulation values and those kinds of pieces of equipment. But there's a report that comes at the beginning of plan review that says this is the proposed design. If I zoomed in, let's see if I can zoom in. Proposed as designed, right? This is the designed evaluation, designed report. When we get to the end, before actual certificate of occupancy, we're going to get a second report, a as-built report from that same, usually from the same company, saying, yes, we made sure, because they're also going to verify that they installed the right insulation, they installed the right equipment, and that everything was consistent with the design. And so whether that can be a third party, that could be a design firm within the building, right? Within the team. You may have, I've seen a lot more departments and especially firms either hiring full-time or hiring as part-time energy compliance staff to run these reports, because it is becoming a bigger component in design around the country? A great question. Like I said, ASHRAE has its own systems and it has its own tables, right? And so those tables are a little bit different. I kind of modified the IEC version that we have in the state in comparison to what we see in a typical ASHRAE 90.1 for just a climate zone set 5. And so we see how a lot of these numbers, just using this below grade wall, they're the same, right? We see that we have this R10 in residential, this R7.5, R7.5, R10, where we start, but we will start to see some deviation, a slight deviations, depending on what we're looking at in some of those components. They're very, you might notice them, you might not. One, for example, is the heated slab, right? The heated slab under the traditional ICC version of the energy code says you have to have that R15 for 36 inches and R5 full slab. Well, the full slab concept isn't something that's in the heated requirements of the ASHRAE standard. So again, it's that, there are minor differences, kind of the same thing we see between the IMC and the UMC, or the IPC and the UPC, right? There's small deviations, but really it's the same concepts. But again, there are alternatives out there that I think are important to understand. So again, when we think about this as an overview, it really does to me become that question of, well, what are we expecting to get in those design details? And what we want those design details to show us is the entirety of what I call the pillars of energy compliance, right? The four concepts that really make a building work. I get projects all the time from around the country, and it's always fun to me to get a nice project that comes in, and then you start reading it. Where was it? It was a Dollar General somewhere. So they sent the architectural, they sent the lighting, but they didn't send any of the mechanicals, any of the plumbing, any of the actual control components of the lighting systems. And so it really becomes this question, this reality of some things we can do as deferred submittals, some things I'm going to need now to verify what's going into the building before we get too far down the road. I had one the other day that actually they did it as a separate foundation permit and a building permit, and what they were trying to allude to, it was the one I was talking about where they've got the metal building. They were trying to suggest that because they had submitted the foundation permit first, it was now an existing building that didn't need to comply with the energy code. And it's like, but you've not put the foundation in. So it should have been identified in that process. And we had there's a whole other ensuing conversation about why that maybe wasn't included. But again, they're all alternatives. So in that scenario, one of the suggestions was, then you're going to need to do a performance rating. If you are convinced that you are not putting any insulation as required by your code and by your climate zone, then go with a performance rating. Because remember, those performance rating, you can trade almost everything away. You're just comparing how that building's going to operate. Excuse me. So we know that the code identifies, both for residential and commercial, but we're looking more commercial today, the different expectations of information supposed to be provided on those construction documents. And again, not to beat the dead horse, compliance path is number one on that list. And so it's important that we identify what we're looking for in those buildings, right? So identify the appropriate code, identify the appropriate compliance path. Now, I'll tell you the one thing, and I did this on purpose, the one thing that drives me crazy is when I see international, especially in a state like New Mexico, which has a statewide code. This is where I would prefer to see a reference to the NMAC, right? I'd prefer to see that, because I want to know that you completely understand that you're not just taking a project, picking up and dropping it somewhere in Roswell or Chavez County, right? That you actually understand that we have a specific set of guidelines, and that you've attempted to at least review to make sure that you've hit those amendments and specific changes that are reflective in the city, in our jurisdiction. So this would be one of those, probably polite conversations. It's not necessarily something I'm going to require revision on, but depending on the note, there'll probably be a note that says that this was reviewed to the New Mexico administrative code, the New Mexico series of adoptions. Just to again pull out and clarify, we're not following the standard IECC. We're following the New Mexico adopted 20 version of the 821 IECC. One of the things that we talk about is, again, understanding within that compliance path some of the documentation that might come with it. Again, we may get a comm check. That's not always an indicator of a compliance path. So what we're seeing here identified as our compliance path is actually just a large section. And so again, I'm going to have that comment that we've seen before before that says, I need to know in greater detail whether we're following the prescriptive path or we're following a performance path. It appears we're following a prescriptive path. And so based on some of the details that are indicated, I'm going to suggest that in this type of a comment, but I'm still going to make sure that they understand I need a little bit more than C401.21. Give me give me one of those nice, detailed names of prescriptive compliance or performance, right? Something that gives me some clue. Because again, if they had put 401.2.2, that would have been ASHRAE, and it would have been, okay, which one of the three ASHRAE paths, prescriptive, energy cost, or performance, are we following under ASHRAE? So again, we need that kind of a detail to really help guide us. Like I said, the four pillars are going to be the thermal envelope first. Again, this is a high-level conversation. We'll come back and talk about these in greater detail. Also talk about the relationship between the air barriers and the envelope itself. But what we start looking for is, again, this is details expected provided in the code in these different highlighted sections. I generally reduce it down to 4 basic concepts, right? To help me review the project. When I'm looking at 100, 200 pages of documents, this is the mindset that I get myself into. Where's my envelope? What's the location? What part of the building am I looking at? And when I get to those spaces, what is that insulation? What are those fenestrations that are going to be a part of that building's thermal envelope? And then how are we controlling air leakage through that assembly? So again, starting with the envelope, we're looking at that. A lot of times I see this or typically one of the things that I'll do if this wasn't referenced on this particular sheet, then what I would say is I generally call out a sheet number, right? So let's say we had this and there was no yellow or orange line around it. I would call out sheet 1.03. I usually look for floor plans and elevations, building sections as places where I'm looking to see. Did you put a note? Did you put a line? We've all probably seen, again, fire rated assembly lines as we look through buildings, especially commercial buildings. And so that's again where I'm saying, if you can draw that line with a fire rated assembly, add me another sheet or put it onto one of these other sheets, that same line or same concept of line, but showing the thermal envelope, because that's going to be important to understand where it is so we're evaluating the right assemblies. And again, one of the things that I'll see once in a while, and we'll talk about it here as we go through. Again, that's going to have impacts on where things are located and how we evaluate other systems like ductwork and other protections. So again, we need to understand where within that building section sheet, where is that thermal envelope so I can maintain continuity. One of the things that I typically will, we make sure we want to do is we don't have a gap like we see here in this left wall, on this right side wall, right? We see it doesn't go all the way to the bottom of the footer, and it doesn't go all the way, at least in the drawing, it doesn't go all the way to it's not creating that continuity. So just to verify, we want to make sure we have a continuous thermal envelope, because if we leave gaps and leave openings, then we're just going to have places where air leakage is going to take place. Condensation is going to accumulate. We're going to have deterioration. I was talking to somebody earlier today about flashing, right? And again, that's part of this process, is understanding how we create those joints and those connections. And we're going to have again a webinar. I think it's in September, talking about the intersections and joints and how we properly seal and what those proper expectations are. But again, this is what we're looking for, is some type of evaluation of the location and the materials that actually make up that thermal envelope. These are the CDs. Separate sheet indicating a lot of this is covered in specific details. So yeah, and I find a lot of that information is also going to be in the spec sheets. One of the things I like to see though is a call out, a record, even if it's a note, right? That's one of the things I like to see. I read through all those detail sheets all the time, and it's a great place. And I like to see where we've called it out and recognize it. Now, one of the things I get a lot of too is all insulation shall be part of the thermal envelope. Are you sure? Because do you really want all, or is it the exterior wall envelope shall? Right? Because when you say all, that means all. And so I'm thinking, and again, that I think that's a great point to make there, Tony, that what we're talking about is getting a finite understanding of what's going on. Because what we'll tend to see is, we might have we might have sound insulation identified different than when we see the thermal envelope. And so again, I think it's incredibly important that we understand what it is we're trying to accomplish, so that when we go back on the field, that everyone's on the same page. And so I think the CDs are or again, those details, those construction details are great. But again, we need to make sure that we understand what is part of that thermal envelope. And sometimes we get what I call flippant answers to some of those conversations. Like I had one last week where the answer was all insulation shall be is considered part of the thermal envelope. Are we sure? Because this is a multi-story building, and you've got sound attenuation between offices. So do you really mean all, or do you mean a particular assembly? Right? And again, drive back to those details. If you're telling me it's wall detail 2, that's great. Then I can understand where 2 is applied, and I can see where it's at, right? And again, I think that's part of it. But when we understanding that location drives us into better understanding the type of material. And again, I had a project last 2 weeks ago where it was designed and approved, and then they come back with revisions because we want to change the insulation. Well, what insulation are we changing? Are we changing the method? And does that change then affect, because not all insulations are the same, right? They have different methods of installation, different thermal resistance values, but more importantly, there are different types of insulation that provide different qualities, right? So are we replacing what was originally intended as a 3-inch, 3 inches of rigid insulation, which incorporated a water resistive and air resistive barrier into a batt insulation, right? So again, there's going to be modifications that I think are important, and we'll talk more about those as we go throughout the plan review series. Remember, they're measured in those measurements are displayed differently. We talk about this every time we talk about insulation. I don't need to know 3 inches of batt insulation. What I need to know is that R value. Does that R value work? I had one recently where the R value didn't work. And so I said, you either need to choose an alternative R value, an alternative material, look at the U factor for the assembly, because you may have enough in the assembly to compare it to the U factor and still get compliance. Remember, the R value is a very rudimentary, singular component evaluation. And so when we look at that U factor will take into account all of the insulation, all of the drywall, all the sheathing, all of those components together to the exterior cladding and the potential air gaps, as long as they're sealed air gaps. We'll take into account all of that information in order to calculate that U factor. R value is a singular component. And so instead of saying I've got an R25 and that's the end of it, do you have an R25 and then what's the wall? You've got drywall, you've got sheathing, you've got backerboard, you've got a different. This one I think had a brick veneer or something of that. So you've got more thermal resistance there. Take advantage of it. Give me that U factor, and we might be able to get into a compliant state. So again, there are different methods to measure that thermal envelope, and so it's why it's important for us to think about how those buildings are built, and again, how much of that wall is there versus. And again, this is something that changes a lot when we start talking about different designs, whether we're using again a wood frame, or in most commercial we're using steel or metal framing, and so then we're going to have different thermal bridging impacts that may come into play. So again, that calculation exists, and you can a lot of times use something like a ComCheck, which is a free online system, uh, to sometimes get to those values. Uh, but again, knowing that R value is only half the battle. It's picking the right information and making sure that it's reflective of the jurisdiction, right? Remember, the code is imperfect. The model code is imperfect, and so whereas the model code saw only 3 climate zones, we know that in reality, and in the state's adoption, we account for those local needs. And again, like I said, Bernalillo County is a prime example. It's got 3 different climate zones within one county. And so it's important to understand a lot of people, especially if they're going back to that first slide saying, or going back to those earlier slides where they're saying, we use the 21 energy code. Well, guess what? Your 21 energy code may not know or may not account for the actual temperature differences in our state. And so you're going to give me the wrong value, right? We see that all the time. But again, that building envelope, and we'll get into this more later, is going to require certain types of materials that make up that envelope, and how are we going to evaluate each of those effectively. I'm going to jump through these slides. They should be, oh wait, I never did do that. I got so into it. Here is the handout for anybody that's interested. Sorry, 40 minutes into it. Now I give you the handout. Do you want to take notes along the way? So again, there are different ways to evaluate whether we're looking at again climate 3 versus climate 4-5, right? If we're looking at climate 7 in parts of Bernalillo County, then again we're going to be looking at this table over here as we evaluate R values. Remember, this is the minimum value for the R value option. When we look at the U factor, that's the maximum U factor. So that is the highest number. You need to go lower if that's what we're looking for. Whereas this, you need to at least have this, and you can go beyond it, right? So again, identify those, verify what's in the keyed notes to make sure that we have those values. Sometimes we'll get those ComChecks, which are an assistive way to evaluate how does the building thermal envelope operate. And so we'll see those values identified, and we'll be, again, just verifying that this has R19 cavity and 7.5 continuous, R19 cavity and 7.5 continuous. I don't need to know if that's an inch or 2 inches. I need to know the R value. Now, I may need to know that inch or 2 inches based on other components and requirements of my design as far as fasteners or those kinds of things. But again, from an envelope energy evaluation, I need to know what is going to be that thermal resistance. And so you might get something like we see down here where it's a 1/2 inch fiberboard thermal break at an R1.23, right? So you can provide both details, just make sure we get our R values. And like I said, a lot of times I see both, where it's 2 inches or 1.5 inches of rigid insulation, R7.5. Same thing for windows and fenestrations that are part of that assembly. A lot of times we'll see that. This is one of those places where I have to go back to the spec sheets and start reading all the different options to make sure I get the right, the minimum value. Now, again, this is going to be 100% selfish on my part to say this. This is, again, one of those things where I reinforce to my design professionals. I'm billing you every time I have to read 1,000 pages of spec sheets when you could have put in the general notes that it's not only the glazing was going to be faced, it's going to be a 1-inch clear Solabond, tempered glass. If you'd put in U factor 3.3, I would have been done. But now I have to go back to the spec sheet and go through, is this 07280500, read 3 pages to get to the point where, again, you could have saved you a couple seconds. And again, those can add up. And again, our jurisdiction where I came from was a little bit different. We were by no means the highest in our region, but we charged $250 an hour for plan review. And so that costs money if I have to read over thousands of pages. Now, again, and when you start thinking about that over and over, because you could just easily put especially when it comes back and it doesn't provide that value. I've seen many where you'll have an incorrect, or you'll have numeric calculation values instead of the actual R value. And so I've had it where it's like, it would be almost like again, there's just different things to think about. So again, this is one of those places where I'd say A6.01, I'm going to please specify the proposed solar heat gain U factors for all the fenestrations. And again, 1, 2, 3, 4, 5, 6, because I know these are all identified in that building's exterior envelope. Remember that U factor is a calculation of how much heat transfer is going through that product. That's why it's used primarily because the window is an assembly, not an individual material, because it's more than just one piece of material. It's panes, it's potential gas, it's also framing around it. Joyce, to see your hand. You got a question? Go ahead. I'll drink coffee while you unmute. Still muted. If you get off mute, let me know. Just jump in whenever if you got a question. But again, when we start thinking about that, that's where it's important. Yep, no problem. Let me move lower. Let me throw that handout in there one more time for everybody. It's in the chat. So again, when we start thinking about that U factor, remember that's the amount of heat transfer going through that product. So if we have a 0.30 window, we are reducing that the amount of thermal energy coming through by 30%, right? And it's really actually it's more of a calculation of how many BTUs. 0.30 is 0.3 BTUs going through that system. That's why we want a lower number is more effective, right? We're letting less energy into the building. Same thing with solar heat gain. It's doing the same concept, right? If 1.0 means we are allowing all the solar radiation to permeate through that material. If we get to a 0.3, we're only allowing 30% of that solar radiation to go through that window. We've seen over time that the different gases and films and things like that have that impact on the solar heat gain. This is the reason why we have different windows and different elevations of a building, and so it's important to understand what windows are doing what where. And again, this is why dogs lay in the front room by the picture window when it's hot out or cool out, because they want to get that solar radiation through there. My dog right now, it's hot enough, she's not even going near that window except to bark at squirrels, right? But when we start thinking about that in the commercial perspective, this can have an impact based on orientation of the building, right? If I've put a more effective window system on a side that has less projection and more direct sunlight, then that's going to again resist the solar heat gain, which is going to affect how much that building is going to require for mechanical heating and cooling. If in that process we've identified maybe projection factors, and we'll talk more about windows and fenestrations later, but if we identify these projection factors, and then some reason we say, you know what, we decided we're not going to put that overhang on. Okay, that may affect the type of window, right? Because again, if you chose to go minimum and you're expecting these windows to be covered, and again, I've told you I've done this before, where I've had a building that was an all glass building, and they put the windows on the wrong side, right? Each orientation, each side of that building, each side of the building had its own specific type of window that was going to be installed, or U factor solar heat gain coefficients. Contractor went out there. As I looked at the stickers and what was on the window, they're wrong, right? They had gotten halfway up and they're like, well, we don't want to take them off. We'll just leave them, right? And it's like, well, you put the less, these windows aren't going to perform the way they're designed, they're supposed to. And so now they're going to get more heat into the building than they were supposed to. And so you're going to have you need to do one of two things: either take them off or contact the engineer and see if they're what we can do to modify it. I'm okay with the modification if the engineer approves it, but that may affect other things. And it was ultimately the engineer came back and said, no, change them. That's going to affect the mechanical system calculations. We're not going to put a brand new system. We've already ordered it, So again, it was a large conversation that took place because of window selection and the proper installation. So as a plans examiner, I'm just making sure it meets the minimum requirements. But again, as an inspector, I'm making sure that it's in the right spots. And again, one of the things when we start talking about mechanical loads, mechanical heating and cooling load calculations, I'm verifying, and we'll talk about that. I think next, again, a couple weeks, we'll get to mechanical. I'm actually verifying that the mechanical load matches my insulation values. And so again, if you're going to modify those values, then I need to know you updated your mechanical load calculations, because it could have an impact. And again, here's another example of where you might find it in different, in a comm check, for example. And then what we're looking at in a building, right? So if it says it's a 0.3 window, I'm expecting a 0.3 window in the field. And that's going to be reflected in again, in the design. Air leakage is another conversation we'll talk about in more detail. But again, we're going to want to have that information up front that says airtight drywall systems will be used and use air barriers at the warm side of all exterior walls, right? They're going to be weather stripped, airtight. Well, we have the assembly. Is there a testing mechanism that's going to be employed? And we know, we've talked about this in commercial specifically, that not all that air barriers can't be an afterthought, because they're going to have different impacts and different methods in which we can test them, right? So what I'm going to ask for is them to verify the testing details, because they may choose to do, again, a bring out a blower door test, right? Do a actual testing, or provide visual verification or of the system's installation. Remember, in commercial, the code allows for different methods of air leakage verification, right? We can either test the whole system, or we can utilize appropriate materials. And so someone's got to verify those materials were installed properly, sealed properly. And then again, is going to need to be somebody who's not likely going to be the building inspector, because the building inspector is there for spot inspections. He's not going to look at every assembly and verify that every seam is done properly. And again, thermal smoke trace, we've talked about that in the past. We'll talk more about air barriers and the methods of installation verification as we go on. So we've talked about everything in the yellow. We talked about things in the green. We've talked about mechanical systems. Mechanical systems obviously are a major component in what we look for. We're going to be doing, again, we'll do a series of classes talking about mechanical systems in greater detail for both inspection and plan review. But what we're looking for are some basic concepts, again, in the mechanical system. So it's not just well, the energy code is the envelope and we're done. No, it's part of that relationship with those 4 pillars of energy compliance, being the mechanical and surface water heating systems. So we're going to be looking for, again, proper design, the appropriate efficiency associated with those pieces of equipment, proper distribution and controls, right? So we're going to be evaluating to make sure that we know they designed the system to work. And again, we're going to make sure that when we look at those calculations, that we are showing that the appropriate materials are in place to support that design calculation. Again, I do it all the time, where I read those manual J's, those manual N's, those heating load calculations for commercial projects, and we've got the wrong design values, right? We've got the wrong insulation values. I had one the other day where they had the wrong, the duct system was was identified as coming from a air handler that was not even connected to that section of the building. And there's, oh, well, we didn't notice that. Well, that's again why we have this checks and balances relationship, because this was a facility that had a gym, and they were throwing the gym under a particular air handling system or heating and cooling system. And I said, well, if my details are correct, that's on the complete opposite side of the building. And you have other units that are closer, and that maybe you have the wrong equipment identified or rooms identified with some of these pieces. And they came back to absolutely, and it had they had made a mistake, clicked the wrong button, and so this gym was not supposed to be on unit 7. It was supposed to be on unit 13. And so again, that's the kind of thing that we want to make sure we address as plans examiners in that plan review process, so that when our guys are in the field, or guys and girls are in the field, that we're supporting efficient and effective construction, right? And so again, we'll talk more about mechanical expectations, but again, we know that what we're looking for is we want a heating load calculation that we want to understand what is this the correct heating and cooling load for that building. Now remember, the code says you have to have a heating load, but if you're going to provide cooling equipment, you have to provide an evaluation of that cooling requirement. You can't just say we're going to give you a part-time, or 50% of your cooling we're going to be able to hit. Nope. If you're providing a system, the code says, both in the UMC, the IMC, and the IECC, that if you're going to provide a system, it has to be based on some mathematical calculation. It can't. And so what we see here is again, a design that says we're looking for. This is one of the things I see all the time, and we'll talk more about this in this heating load calculation sheet. You've got the wrong jurisdiction. I appreciate you thought it would work, but it didn't. It was error, absolutely. But I need it for Hobbs. And I know that Wyoming is completely different from Hobbs. May it be just as beautiful between the two, but Hobbs is a little bit more happening when it comes to the heat index, right? And so, again, I need to make sure that your cooling load, if you're going to have cooling, is going to be appropriate. And then after I've evaluated that design, then I get into the equipment selection, right? I make sure that a lot of times I see this in a comp check. If I don't see it in a comp check, I usually have to remind contractors the first couple times. I need to see that equipment efficiency rating, right? Or provide me the details. If I have to, but again, remember, I'm billing you by the hour. And so I'm billing you to look through 15 pages of train documents to figure out what's the efficiency rating for this specific size unit in this specific configuration. I can do it. It's going to cost, right? And so a lot of times it's easier to drop in a efficiency rating here than it is to pay me to look for it for you. Just throwing it out there. And again, not every jurisdiction has the same billing protocols as what we do. But again, that is a reality that we see sometimes. So again, I'm evaluating those against the tables that are in the code. And then again, in the field, I'm going to be verifying if this is supposed to be a 21 SEER system. I'm looking for a 21 SEER system in the field, because again, I'm making sure that we have consistency, or that we've had plan review changes. Same thing with ducts. We talked earlier about how that it's important to understand where the thermal envelope is in relation to those duct systems, and then that we have the appropriate controls. Again, we'll talk more about this as we go through this process, but as an overview, we understand these are important concepts, and we need to understand those sequence of operations. How are things going to activate, turn on, turn off? Where is this the right type of thermostat controls? Are we looking at continually operating or intermittently operating fans? And how are those going to be affected by what the code requires? We'll get more into that and the location, the types of controls as we go through the rest of our plan review series. Same thing with water heating systems. We need to know that there's an actual heat, that you've actually selected this equipment to meet the demand of the building, right? Now, we all know that we've talked about plumbing last week in our webinar. the plumbing code doesn't give us a maximum number, right? It tells us we have to, and the mechanical code doesn't give us a maximum amount of equipment size. But what we are looking for is that there is a load associated with it. Now, whether or not the future generations of the code start to pull in that concept as part of the conservation work, that may happen. I've seen it brought up in several different jurisdictions. But again, if we want to make sure that the water heating systems that we employ, that we install in the buildings, can meet that load, and then we got to make sure that piece of equipment meets the requirements for efficiency. Then we get into the same conversation with mechanical. We start talking about distribution, right, and how we insulate that pipe to again resist water accumulation and condensation accumulation, as well as yeah, Dennis, I can get you a copy of that fire presentation. Just if you want to email me, I can get this to you. Sorry about that digression. But again, what we're looking for in the energy code is those kinds of insulation expectations, right? Where are we going to see that insulation, and where are we going to have those maybe heat traps that we're looking for in the code, right? Lighting, we've talked about lighting a couple weeks ago, but we'll get back into it in greater degree later in the fall. But again, we're looking for, when does it comply? What complies with the energy code? And it's all about the lighting. We're not calculating how much energy is in the coffee pot yet, because we'll start talking real serious then, right? But we are talking about lighting and when it is and is not on. So if you do have, so what we're looking at, the code will get into, and we'll talk more about, when do we have sleeping units versus general lighting? What are those controls and those inherent to those different designs? And again, there's going to be a report that's going to be generally easy for, say, this is the amount of allowable power to be used for lighting, and this is how many fixtures we have, and show those comparisons. But then we can get into the other systems on controls and what that looks like as we get further into that conversation. Again, we're looking for different sensors and controls in the installation and the evaluation, to make sure that, again, do the pieces of equipment and their installation look right on plan review. So again, it's all about identifying the type of lighting, identifying the amount of controls, whether that's on the interior or the exterior, right? And so we identify where's the control for all of these exterior parking lights. We know one of the considerations in the energy codes related to the power utilization is going to be in section 405.13, EV power infrastructure. And so we know that, and this is a conversation we've had before, we will have again when we get to that time in our deeper dives. But remember, the energy code says there are certain amounts or number of EV supplied and EV capable spaces that the code is requiring. Not just local jurisdictions, but it's a part of what we expect to see in a building, and what it means to have supplied equipment and versus capable spaces. I know we got 2 minutes, and what's missing in this conversation is the concept of additional efficiency packages in commercial projects. There are about 15 different types of credits, which come out to about 32 different options that a project needs to utilize to get to their 10 required credits. Some of these may be reduced power. They may be more efficient water heating systems. And so, again, there's going to be components that we're going to be seeing in a building. Like this one here, where we've included a more efficient thermal envelope, reduced the air leakage, and then put in that fault detection in our equipment, and we're able to get to our points. We actually exceed. We needed 10, we got 13. So I know we're at the very last minute, so if anybody has any questions, let me know. The recording. Let me make sure I hit record. Yes, I did hit record. So there is a recording. We are working to get that up and onto the website, so you'll be able to view those. If you do have questions, please feel free to reach out to me. If there's something specific, please always feel free to reach out with an email to either myself or to our New Mexico helpline. Especially if you don't see something, find something, it might be easier just for me to send it to you personally versus you waiting to find out when it gets updated. Next week, we're going to get into what is some of those expectations for documentation. So documents for submittal. Then we'll get into the beginning of our inspection series. We'll get back to air barriers, comm checks, and then we'll get into this whole concept of mechanical systems starting in August. On your survey, if you've not already provided your AIA or ICC numbers, if you have particular questions or topics you think would be helpful, please make sure you use it. You can also reach out to us through the New Mexico helpline at shumscoda.com. If you're interested in hosting one of our future trainings in your jurisdiction, or if you have some more conversations that you think would be helpful, topics for in-person trainings, please let us know. Like I said, the current slides, the current website for for our program is here, and our offices are trying to migrate to a more user-friendly version. But they're IT department, so they're worse than waiting on the utility company, right? So again, if you have questions, feel free to reach out to us at the helpline. I appreciate you being here. Everyone, be careful, be safe this Independence Day, and make sure you thank a veteran and the families of those who have served. Appreciate you. Have a great long weekend, and we will see you next week when we start talking about what needs to be submitted.